Jaden Fed, and today we're going to be talking about DNA models. Credited with the discovery of DNA was James Watson and Francis Crick. However, they only made their discovery after they borrowed Photo 51 from Rosalind Franklin, a woman. From then on, they began to make a double helix model of DNA. Along with the observations made of Franklin's Photo 51, the DNA model was also based on the arrangements of atoms that were observed, X-ray crystallography of molecules, structure of biological molecules, and Chargaff's rule of bases. The model helped change and impacted our understanding of inheritance by revealing how genes are replicated, how genetic information is stored, how genetic mutations occur, and provided key information that helped and are still helping us decode the mysteries of life. It also provided undeniable evidence that explained both the stability of life and its mutability in evolution. And that brings us to my model. I made my model easy to understand by including labels and a key. I also made the different elements of DNA easy to differentiate and made the model large so that everything can be seen easily. I don't really think my model is super accurate. I mean, if you look at it, obviously some pieces are falling apart, and of course this isn't the actual size of DNA. However, I tried my best to keep things into scale, like how I kept the deoxyribose sugar bigger than the phosphate molecule, and how I made the hydrogen bonds weaker than the covalent bonds. I chose materials that most accurately represented the function of the part of DNA that they were trying to replicate. For example, the hydrogen bonds here are made of paper clips because they can come apart just like hydrogen bonds. This small paper clip represents a purine, and this big paper clip represents a pyridine. This wire here also represents a covalent bond, which is stronger than this hydrogen bond. And the different colors and labels indicate what type of base they are. Altogether, there are a lot of things wrong with this model. First of all, it's in a DNA ladder form rather than a helix, which is more of a spiral. It's not to size, obviously, and I don't know if these are the actual shapes or colors of the actual components of DNA. However, this was just more of a give you an idea of how DNA looks up close. So let's do one more rundown of DNA. So first you have a nucleotide, which is made up of a phosphate molecule, a deoxyribose sugar molecule, and a base. The bases are thymine, cytosine, adenine, and guanine. And so the bases that go together, which is Chargaff's rule, is adenine and thymine and guanine and cytosine. So in any DNA strand, they'll always be together, like they can't mix, but they can face either way on a DNA strand. Then you have a hydrogen bond and a covalent bond, and the covalent bond is always stronger. And then finally you have the 5' and the 3' end, and the 5' end is the end with the phosphate molecule, and the 3' end is the side with the deoxyribose sugar molecule. And on DNA you have two strands and they're running opposite ways, so on one strand there'd be a 5' end, and then if you go directly across, then on the same end it would be a 3' end on the other side. There are so many kinds of models. Well, anyways, this has been a video on DNA models. Thanks, bye!